This time, we will now be considering what if the backfill is cohesive. So if the backfill is cohesive, that is the cohesion is greater than 0, then the active earth pressure is determined using this equation. So gamma is the unit weight of the soil, Z is the depth, K prime A is the coefficient of the active earth pressure, and then alpha is the angle that the backfill makes with the horizontal. So the K prime A is determined using this equation. It's a lengthy 1 equation. And other than using this equation, we can also determine the value of this coefficient with we can also determine the value of the case of A using this table. So this table is a variation of the angle of friction, the alpha angle, and at the same time, the ratio of the cohesion divided by unit weight of soil multiplied by the depth of soil. So again, if the soil is cohesive, there are two scenarios that can occur. Either the force unit will occur before the tensile cracks or after the tensile cracks. So we can determine the depth of the tensile crack using this equation. So that is this of C is equal to 2C prime divided by gamma, the quantity multiplied by the square root of 1 plus sine the angle phi divided by 1 minus sine the angle phi. Considering now the passive pressure, in a similar manner, the Rankine passive earth pressure for a wall of height h with a granular sloping backfill can be represented by the following equation. So passive earth pressure is equal to the unit weight multiplied by the depth of the soil multiplied by the coefficient multiplied by cosine alpha. So again, the alpha is the angle that the slope makes with the horizontal. And then to determine the value of the coefficient, we shall be using this equation. And other than using this equation, we use the table. And this table is a variation of the angle of friction, the alpha angle, and likewise the ratio of the cohesion divided by the unit weight multiplied by the depth. Let us now consider a sample problem. So for the retaining wall shown, H is equal to 7.5 meter, unit weight is 18 kilonewton per cubic meter, angle of friction is 20 degrees, cohesion is 13.5 kilonewton per meter squared, and the alpha is equal to 10 degrees. Calculate the Rankine active force per unit length of the wall and the location of the resultant force after the occurrence of the tensile crack. So we have here the wall, we have here our retaining wall that is holding this backfill, and this backfill is sloping, and it makes a slope of 10 degrees to the horizontal, and then the height of this wall is given to be 7.5 meters, and the properties of the soil is also given. The unit weight is 18 kilonewton per cubic meter, and then the angle of friction is 20 degrees, and then the cohesion is given to be 13.5 kilonewton per meter squared. We are required to determine the Rankine active force, but note that this is after the occurrence of the tensile crack. And then we are also to determine the location of the resultant force after the occurrence of the tensile crack. So for our solution, first we have to determine the value of the coefficient of active earth pressure. And then after that, we can determine the active earth pressure, which we will be using to plot the pressure diagram. So after plotting the pressure diagram, we can now solve for the active force. This is simply the area of the pressure diagram. And then we can now locate the resultant force. So let's start. So let us solve the value of the coefficient of active earth pressure using this table. You can also use the equation, but let's use this table for this particular problem. So again, the table is a variation of the angle of friction, the alpha angle, and at the same time, the ratio of the coefficient, the ratio of the cohesion divided by the unit weight of the soil multiplied by the depth of the soil. So the angle of friction is given to be 20 degrees, and then our alpha is also given to be 10 degrees. Alpha, again, this is the angle that the slope makes with the horizontal. And then let's solve for this value. So that becomes cohesion is given to be 13.5, the unit weight is given to be 18, and then the depth of the wall is 7.5 meters. So this is now 0.1. So from the table, first let us consider the angle of friction. So we have here 15, 20, 25, and 30. And since our angle of friction is 20 degrees, so we are on this category. Next is we shall now consider the alpha. So our value is 10 degrees. So we have here 0, 5, 10, 15. So we are at this 10 degrees. And the next is the value of this quantity. So this is 0.1. We have here 0.025, 0.05, 0.1, and 0.5. So since our value is 0.1, we are at this category. And this is the intersection of our plot. So therefore, this becomes now the value of the coefficient of active earth pressure. So that is 0.377. So since you are able to solve for this coefficient, we can now solve for the earth pressure, active earth pressure, using this equation. So substituting, we know all the value. Unit weight is given, depth is given, alpha is given, coefficient, yes, we were able to solve. So we can directly substitute this equation, and that becomes 18 times the depth is 7.5 times the coefficient 0.377 times the cosine 10 degrees. So our active earth pressure is equal to 50.122 kilonewton per meter squared. So from here, we can now plot the pressure diagram. So if we are to plot the pressure diagram, it would look like this one. So we have here your angle alpha, the slope of the backfill, and then we have here the length, which is 7.5 meters. And then it is at this point that the tensile crack occurs. So we would be needing this distance, this of C, and we can determine this distance with the following equation. So that is 2C divided by the unit weight, the quantity multiplied by 1, plus sine angle of friction divided by 1, minus sine angle of friction. So since all these parameters are known, we can directly substitute this. So that becomes 2 times 13.5 divided by 18 multiplied by the quantity 1 plus sine, the angle of friction is 20 degrees, divided by 1 minus sine 20. So kilonewton and meter squared, kilonewton, cubic meter will cancel out. We are left with 1 meter. So this of C now becomes 2.142 meters. So that is 2.142 meters from this point up to this point. That is 2.142 meters. So this is the distance before the tensile crack occurs. But what we are looking is after the occurrence of the tensile crack. So next is we can now determine the value of our active force per unit length, which is the piece of A. So sabi natin, this is simply the area of the pressure diagram. So this is our pressure diagram. This is the earth, active earth pressure that we were able to solve a while back. And the area of triangle is simply 1/2 base times height. So substituting, that is 1/2 times the base. So this is the value of our base is 50.122 kilonewton per meter squared multiplied by the height, this distance. So this distance is 7.5 meters, the total length of the wall, minus the depth of the tensile crack, which is 2.142 meters. Simplifying, our active force is 134.277 kilonewton per meter. So this is now our answer. So finally, we can now determine where the resultant force is acting, and sabi natin that is simply 1/3 of h. But the height that we will be considering is just this height, since again we are considering after the occurrence of the tensile crack. So that becomes 7.5 minus this distance, the total length minus this distance, so that we are left with just this height divided by 3. So z is equal to 1.786 meter from the bottom of the wall. So if we are going to plot this from the pressure diagram, this is the distance, 1.786 meters from the bottom of the wall. So doon nag-a-act yung resultant force natin.